हेलो। आ रहा। हाँ, हाँ। हेलो। आ रहा हूँ भाई, 1 मिनट आ रहा हूँ। अरे तो जहाँ तो स्टार्ट करना, मैं पहुँचता हूँ। तो स्टार्ट करना, मैं पहुँचता हूँ। हाँ।
Hi everyone. I think we can now start. It's 16 already. So let's begin with the session. Hi, my name is Akash Khandelwal, and I'm the current GDSC lead at IIT Goa chapter. And today we have a very special hands-on workshop arranged for you all. The speaker of the session is Abirami ma'am herself. Let me give you all a little brief intro of her. She has about 17 years of experience in application development and leadership in the areas of databases, data management, and analytics across industries, with a few patents filed in the data management and data science areas. Currently pursuing doctorate in business administration with specialization in machine learning. She is a certified yoga instructor, practitioner, and blogger. And currently, she is a developer advocate in Google, specializing in Google Cloud databases and data to AI journey. She is also the founder of Code Vipassana, a non-profit program that I have myself attended in the past. Code Vipassana basically focuses on empowering developers and practitioners with hands-on tech in a series of free online app dev workshops that are themed to cover every aspect of the data to AI journey. Code Vipassana was even awarded by Analytics India magazine and received award by John T. Rhodes himself. Also, she was recently chosen a Google for Startup official mentor. Other than other than being the speaker of numerous sessions all over the year, she was also a speaker at this year's Google Cloud Next at Singapore. So, without any further ado, let's start with today's sessions. Abhirami ma'am, over to you.
Thank you so much, Akash. Hi, everyone. Happy Thursday and 6 p.m. I know it's at least not later than that because it's possible. I mean, it's possible the other sessions this week or past week has been after 8 because my days were hectic. But today I thought it's closer to weekend and I didn't want you to stay that late because of me. So I thought, okay, let's do it at 6. Yeah, thanks everyone for joining. Thank you so much for the introduction as well, Akash. You had done a detailed, thorough um, search for some of the things, but really appreciate it. I'm excited to talk to you about data to generative AI journey. I want to also start asking you: is this the entire group from GDSC, or you're also folks from other community? Show of hands, or you can use the chat to respond. Mostly from IIT Goa. Okay. And how many of you are familiar with cloud computing or from Google Cloud background per se, specifically? Okay. Any others, like out of the 30 odd folks that we have here? Do you have any? How many of you are brand new, like completely new for cloud or Google Cloud for that matter? Is the first session, something like that? Just give your hands up. Okay. You can just use your thumbs up emoji also from the reaction menu. Okay. All right. So we have a mixed group. So please let's keep this interactive. If you have any question, please feel free to type it in the chat. I'll be monitoring the chat here and there. I'll take some breaks to see what's there in the chat. But since we also have some folks who are absolutely new as well, so we'll keep it at that level. Like most of the sessions, hands-on sessions that I do, I try to keep it uh, in a broader range so that people who are absolute beginners can also connect to it, and those who are intermediate to advanced can also learn something out of it towards the end of the hands-on or towards the hands-on during the hands-on itself, right? So first of all, before starting or entering into the session, I'm going to ask you one question: what is cloud for you? Like, what do you think is cloud? You don't have to speak or anything. Just use the chat and in one line, what it is, what does it represent to you, and what is cloud computing to you? You can type your answers in the chat, or if anyone wants to speak up, just put your hand up and we'll unmute you and we'll have you speak. What is cloud to you? Okay, global platform to deploy your service at its best. Okay, any other answer? What is cloud computing to you? Anybody else wants to give it a try? Ayushi says storage and processing of data globally online. Okay, anything else? What else? Give me a few more answers. It's a hands on session. Let's keep it interactive. Anything else? What does it represent to you? Somebody wants to speak up and answer. Parth, your hand is still up. Do you want to say something? Do you want to answer? What's cloud? No? A platform to host websites, applications, and also run models and create data pipeline. Okay. So we have three answers and that's it. But I was expecting a lot more because some people talk about deployments. Some folks talk about databases. Some folks talk about ML pipelines, like Soradeep right now. Some talk about handling data online, and some talk about storage and processing. So whatever branch of software or technology that they are close to is what they think cloud does. So I often get the same answer from a lot of folks. For every session I go, if I start from the scratch, if it's a session like this where I ask this question, what is cloud computing? This is a very similar set of answer, and also this kind to use virtual servers instead of physical ones, making it easy to scale. So yeah, these are all correct answers, but these are not the only answers, right? These are all together. Like if you see one, you cannot leave any one single branch out of this. Like you cannot leave out platform to deploy. You can't leave storage and processing. You can't leave models and data pipeline and hosting. You can't leave out virtual servers, right? You can't leave out scaling. So all of these things together. So how would you explain that? Let me share my screen quickly. All right, just show a quick thumbs up if you're able to see my screen. Okay, thank you. So how would you explain what is cloud? So simply if someone asks, because it has a lot of things. So that's why this very simple, very basic level definition for it is getting things done using someone else's computers, because you want to do everything, right? Like you want to store, you want to use ML, create ML models, you want to build networks, you want to deploy, you want your application to be scalable, you want to host something, you want to do analytics, you want to perform visualization, you want to support upgrades, patches, provisioning, hardware provisioning, what do you call that, access controls, networking, failure recovery. So you want to take care of all these things, but getting it done by a provider or by on someone else's computers, that's what is cloud. So a lot of people always wonder, because when you're absolute beginners or when you're starting, this definition or this understanding is really important, that it's not just one part or one branch of technology or software. It's all of these things. You can do all of those things like software, DevOps, development, networks, virtual machines. So all of those things together, you will be able to get it done through a provider or in somebody else's computer. When I say somebody else's computer, it's your provider's resources. So that's what we call cloud. So this is important, just so you know, because it's not just one thing, it's all of these things. Now, let's take it one step further. So let's assume that I'm giving you a requirement, right? I'm giving you a requirement where you have to build an application. Let's take the cricket match application that's going on, right? Because the World Cup is going on, you're all curious, you're watching all the matches. Now you want to do some analytics of your own before you even see what the results are, before you even find out like who's going to win, who's on the table now. So before this happened, now we are in that stage, we are waiting for the semifinal to start. But even before all of this happened, when the knockoff matches were going on, we didn't know anything, right? We didn't know the performance, but all we had was access to historical data. We had access to current data, right? Whatever, if current innings, if second innings is going on, we have data till the beginning of World Cup to the first innings of the current match. So you have data that is made available to you. Now, I'm going to give you a requirement saying that you have to build a full application, a full analytics solution by taking data that is taking historical and streaming data and making an interface which, as an end user, your friend or somebody else in the call or someone, some other client of yours is able to use that interface and pass some questions and understand the answer, understand about how players are performing, which how teams are performing, who has the higher edge of winning, like who has the higher probability of winning something depending on where the match is happening. So all those things they should ask question and get answer. But I'm telling you that you have to have scalable and reliable runtime. I'm giving you the requirement that suddenly from 10 users, your app could become something that gets accessed by 100,000 users because I'm going to use a social media influencer to talk about this application. So you have to have highly scalable and reliable runtime. What is runtime? Runtime is where you build and deploy. You actually runtime is something that runs your code, the code that the 4-line code that you write or anything that you write. Let's take the example of addition, right? A plus b equal to c or 1 plus 2 equal to 3. So that line of code that you write in order to get that answer, if that gets compiled and deployed and built and everything, so that particular the process that contains the process that execute code is what runtime is, right? So I'm telling you, it has to be scalable and reliable, no matter what time of the day is, which part of the world it is. If they send a request, your application should be highly scalable and reliable. Why scalable? Because I'm going to use an influencer and they are going to talk about it, and boom, your application is going to get 100,000 hits. Now, it has to be flexible and the analytics need to be fast. Why? Because multiple people might be querying at the same time and I want quick results. If I say who will win the match between India and Bangladesh, for instance, on a ground that's more familiar to India, but at the same time, the time of the day is so hot that this time of the year, so Bangladesh has a higher chance of winning because of their natural practicing conditions. Something of that sort. I'm just making stuff up. So if I ask a question like this, the analytics should not take so much time to understand this or summarize this, write query in the background and bring you the answer. It has to be fast. Now, machine learning, there should be forget the use case that's mentioned, cheating detection. That's not the use case we are discussing. Let's say you have to use machine learning for naturally understanding the language, the question that you're putting in English. It has to use NLP, natural language processing, and understand the question and translate it, translate in the sense, convert it into queries and run the query and fetch the answer for. So you have to do machine learning as well. And then I'll say you have to do data visualization, like show me in charts about the trend of a particular country or a particular series or something like that. All of this I give you as your requirement for this app. But at the same time, I'm telling you, you should not think about provisioning hardware, software. You should not install anything. You should not upgrade anything. No security patching. You should use something that's very straightforward and something that does not make you think about all these processes and steps, right? You shouldn't be paying for just writing code. You should only be paying for what you're using, and you should not be dealing with your failures. The provider should be taking care of all that. Or I'm just giving you this requirement. You should not be thinking about these things. Now, if I give you such a requirement, let me ask you a question. What will you think about first? Now, this is your requirement. Okay, so now this is your requirement about building you have to build something like this. Now, what will be your first line of thought? What would you do? I'll say that data is available. You can use whatever source of data that is available. So you'll bring in the data that is available in the form of sheets. You have data that's available as CSV. You have data in some other website. Now you have to bring all this browser-based data, CSV data, all this from everywhere. Now, what is the first thing that comes to your mind? What do you think of? What do you do with the data that you collect, that is coming in from all these places? Like, what do you do it? What is the first step? Store it. Absolutely, you just nailed it, Ratikanta. So storage is the first step, right? Because yeah, ingestion is the first step, but let's, I already told you data is available in different formats. Now let's assume that you have ingested it. Either you get it manually because it's analytics application, but if I'm talking about the entire pipeline, then you have to think about how would you ingest the data from outside sources like CSVs and browsers into your ecosystem or into your architecture. Now that would be the first step, but in this case, let's start from storage. So you have to store it. Let's say you decided to store it in a relational database format. Then what is the next thing? What do you do with the data that is stored for the requirements that I provided you? What is the next step? Here, if you want to see the requirements, I'll go back. What is the next step after storing it? You can use the store data using APIs. Okay, what are you going to use it for? You've stored it. Now you want to do some machine learning on top of it, train the models or whatnot. You have to build application, and to build application, I've already given you the requirement that it has to be scalable and reliable runtime. So you're now thinking about how to make it available serverlessly. Why? Because it has to auto scale. It has to pay. You have to pay only for what you use because those are there in the requirement, and you should not maintain servers. So if it's an application or pipeline that you're building, you have to deploy it serverlessly. So does serverlessly mean not maintaining servers? No, it does not mean that. Serverless means the provider is going to maintain it for you, and you will only use the service. You'll only deploy it. You will not actually maintain the server. So that's what it means. All right. So you've created ML models, or you've just used an API for ML models, and you have understood the question. Automated service is a very generic terminology, but automated service for what? You're building the automation, let's say, and then you're building the application, you're deploying it serverlessly. Same thing with visualization. You're probably using Looker Studio or something of that sort, right? Because you want to get visualization done. And BigQuery, let's say you're using BigQuery to get the result back from queries, or the storage. Let's say your relational storage option that I mentioned to you is BigQuery, and then you can perform analytics on top of that. You can perform ML. You can do anything. Now, why did I bring up this use case for you? Because I brought up this use case to you because I wanted you to understand the difference between doing all of this by yourself with independent components, difference between that and getting this done using a cloud provider like Google Cloud, because all of these are available as services and managed services. So you can use some of these and not worry about the underlying mechanism or the underlying architecture of these components itself, right? So this is what I want you away from the theory part that we've discussed so far. So let's dive into some important things. We already discussed storage. I won't go through all the available storage because if I go into all those things, it will become highly theoretical. But I just wanted you to know that we talked about storage. There are several options in Google Cloud depending on the structure and format of data. Because we spoke about storing the cricket data from historical data sets and historical matches and current matches in relational data. But imagine if you get questions around which player is in the highest form, or which bowler is likely to throw I forgot what it's called. What is it called when it comes till your above your shoulder level? I forgot what it's called. So you will. There are different questions. Not bounce. No, it's not even a googly. There's some other name for it. No, not wide, not Nova. Sorry, it's okay. We'll get to that later. It's called, there's a nice name for that ball that comes above your shoulder. Anyway, it's not any of those things, but let's say that that's what the question is. So there are a lot of other things that you have to also analyze, right? It's not just relational or structured data. You'll have data in the form of videos. You'll have data in the form of live streaming posture and movements and motion recognition. So you have to track those data points as well. And you have to deal with semi-structured data, unstructured data, as much as you deal with the structured data. So there are different types of storage according to your data that is being ingested. So deciding factors for choosing your database are too many. We are not discussing all those here, but you have to consider what is required, what is best for you, and then choose the database and the rest of the architecture as well. That we have discussed. So front time, I want to show with a hands-on demo, but we remember we talked about serverless when it comes to runtime. There are 3 important serverless options that's available in Google Cloud. More than 3, but we are only going to talk about one hands-on today, but I'll just name a few, like Cloud Functions is there, Cloud Run is there, and we have App Engine. But Cloud Functions is for mostly single-page applications. Like you write in the same cricket example itself. Let's say every time a ball is done, every time a ball is thrown in a particular over, every ball the data is coming in and it has to update, even though it goes into the transaction, streams into the transaction and then streams into the analytics database as well. But still I want to call, I want to create a trigger or pull, I want to initiate a trigger every time a ball goes into the ball record goes into the table. It should trigger something that will probably calculate what will be the Duckworth lowest score if the match has to stop right now because of rain or something like that, right? So if let's say I want to call another use case, so it's a simple one-page application, and it's not a full stack app that has so many dependencies and external integrations, right? It probably is very quick. So some applications like that, which are mostly like limited in scope and does not have too many dependencies, and it's not like a full stack, like heavy stack application, those you can deploy in clouds. Cloud Run is for a full-fledged application. This entire problem that this entire requirement that we've opportunity that we have been discussing about would become in itself an application that can be containerized, or in other words packaged and deployed in Cloud Run at the click of a button. Both Cloud Functions and Cloud Run. The difference between these two services is that in Cloud Functions you deploy straight from your source code. You don't create a container. Behind the scenes it takes care of it for you. Whereas in Cloud Run you are writing code in whatever, in your local or in your directly in the cloud editor, cloud shell editor, but ultimately you are deploying it as a container. You're packaging it and then deploying it. So that is the difference between the two. And there are other services as well, but we are only going to discuss these two, and we'll see a hands-on for runtime. And we discussed about visualization. So check out Looker Studio if you want to create quick charts and graphs and make it available as an API as well. So all of these things are possible. And then you can also do machine learning. There are different things. There are machine learning custom, machine learning auto ML, where Google Cloud decides what algorithm is best for you by looking at your data and all that. And then you have AI APIs like video API, translation API. You have image text extraction API, entity recognition. You have classification API, video analytics, image. There's so many APIs for artificial intelligence topic. And then there is the concept of generative AI. That is what we'll see at the end today. So there are three things we'll see hands-on. One is the serverless part, the runtime part, because no matter what you do, ultimately you want to make it available as an application or as an endpoint, so that anybody else who is looking up to you for the application that you're implementing will have it available as an endpoint or as a REST APIs, so they can use it. So what is an endpoint? An endpoint is a URL which is which is on the REST or HTTP protocol, HTTPS, secure HTTP protocol, which is available for other services to consume. So that is what we'll create with Cloud Functions today. And then we also will talk about ML, the difference between ML, AI, and generative AI. And we'll do hands-on ML and we'll do hands-on generative AI and see the difference between the two. All right, are you ready? Is there any question before we get started with the hands-on? I'll give you some links which you need to click and keep it handy for us to get started. Thumbs up if you're following me till now. Yeah. Okay, perfect. So we are going to see what we also already spoke about what a runtime is, but we are going to take Cloud Functions. We'll do a simple Cloud Functions application and see what the endpoint looks like and how you deploy it and all that. So before we get started, I'll give you the credits link so you can actually use it for the generative AI till the generative AI session today. Right? You can even use it till it will be valid for another 7-8 months at least. So you can use it for your self-learning as well. Whatever we are doing today is not going to cost you much, or this credits will not be used up entirely. So click this link right now. This will give you free $5 credits that will be added to your Google Cloud account. So click this link. It should open up like this. And in here, you will have to click here to access your credits. And once you click that, it will give you other details. Just verify your details. And in the bottom, there's a button that says click to continue or something like that. Just go ahead and do that. Accept and click continue. Somebody is unmuted. Please mute yourself. Thank you. So this is what you should see. In my case, I've already used up. So don't worry, you should not see the message. If you're seeing the message, that means you have the credits remaining in your account. Don't worry about it. Just carry on to the next link, which I'll provide. But those who are able to go past accept and continue, you should be landed successfully on the console.cloud.google.com page. Let me give the other folks that link. You don't have to click that if it automatically takes you to the Google Cloud Console homepage. Sorry, remove the project part. You should not click the project name. Ignore the last message that I sent. Okay, please ignore that. I'll send you the right landing page, the one that I've sent now, console.cloud.com. Click that. You should be able to see this Google Cloud Console's landing page. All right. So, show of thumbs, how many of you are able to successfully create this? Anybody else? Yeah. All right. Perfect. So now let's get started. Before that, I'll give you, yeah. No, right now, for now, we have everything we need. I've also given to you the console.cloud.google.com link, which is the homepage, landing page for Google Cloud. So open that. Now, in the search bar, so you should also make sure that you're able to see in the drop down next to the Google logo in the top left corner. The third object that you should see is a drop down list that shows your project ID, which says, in my case, my project 93741. You should also be seeing a project ID there. If you don't see, click that drop down and click this new project link. If you click this new project link, it's straightforward. Just provide a project name and don't worry about the organization. It'll just leave it to the default value and say create. And once you click create, it should create that project. And if it is not allocated to a billing account, it may not let you do the next step that we're going to do. So in that case, just click this navigation menu, the hamburger menu on the top left corner, the 3 lines. Click that and go to billing. Click billing, and it should open 2 options in your case, because if the billing account is not linked to your project, ask you to manage billing or create billing. In your case, I don't know if it's not showing manage billing, then it's fine, which means that you, associate or link a billing account. If it doesn't show link billing account, it means that your project is fine. It has a billing account linked to it. If it is not linked, it will ask you to link it. It will open 2 options. So choose the link a billing account option and choose the account that has the $5 credit added just now, which you've added, right? So, and this is how you link a billing account to a project in case it's not by default. All right. In my case, it's already linked by default, so I'm not going to do anything. You should do the same thing as well. All right. Once this is done, just click the logo, the Google Cloud logo. It will take you back to the landing Google Cloud Console page, and you should be good to go. All right. Show of thumbs. How many of you are able to set this up? Can someone confirm? Project ID and billing. Others? Anybody else put it to work? All right. Uday has a question. How do we get the link? How do we link the accounts again for the billing part? No, that's what I said. So if it's not linked by default, if you created the project just now or the project got created when you click that link, you don't have to do anything. It's automatically linked. But if you just created the project and the billing account is not linked, you can always verify that clicking the navigation menu, going to billing, and you should be able to see that in the billing page. If you scroll down, it will show how many credits are remaining. If it shows 0, then associate go to manage billing and associate a billing account. In my case, it won't show that because I only have one active billing account. Like in this drop down, if you see, I have only one active billing account. So it is already associated. That is why I'm seeing this credits remaining. In your case also, you should see $5 credits remaining. All right. So good. Kalyan, are you able to get it now? What is the error you're seeing? What is the error you're seeing, Kalyan? Just click credits link. If you did click the credits link, you should be fine. And then don't click the second link which I sent. Click the third link if you want to land. Okay, Rati has got 5 credits. Let me ping the link to the credits again. If you have issue with some email ID, it's possible. Just make sure you've opened another link, another credits link. Sorry, another Google Cloud account. Sorry, another Google Gmail account or any other account, and then click the link. Then you may probably get it. All right. So once that is, we have to keep moving in the interest of time. So I'm going to move on to the next step, which is creating the cloud function. All right. So here I am in the console page. I'm clicking the Google Cloud logo. We can go back to the home page. So in about 5 to 10 minutes, you will have a cloud function created in your favorite programming language of your choice. In my case, I'm going to do it in Java. You can feel free to follow me and do the same thing in Java if you don't have a language preference. So I'll also paste the changes that I'm making in the code. I'll paste the whole class in the chat. You can copy from there and execute in your code. Okay, so that is also a possibility. So let's get started. Before that, I got a message. I see a message here. No message. Can you tell me again how to reach the credit link? I've given the credit link. No, you just have to click that. Kalyan. Just have to click that, add the credits, and then open Google console.cloud.google.com. That's what we discussed. By default, it will land you in console.cloud.google.com. So you shouldn't be doing anything, but I'm still pasting it anyway here. In case you're lost in between, just click that link and go back. All right. So let's get started. So this is the Google Cloud Console homepage. I went here by clicking on the Google Cloud logo. Now in the search bar, I'm going to type cloud space functions. All right. So you should see cloud functions, cloud run and whatnot in list of items in the products and pages list. But I'm going to choose cloud functions because that's what we want to create and deploy now. So I clicked it here. You should be able to see the cloud functions home landing page, and then you see the list of functions here. So click create function because if you won't see any list item, because if this is your first time creating a cloud function, so don't worry about it. Go ahead and click create function. So once you click create function, the configuration page opens up. Make sure you've selected the 2nd gen environment because that's the most updated one, most recent generation environment. They'll make all the latest changes here. They've made it advanced. So 2nd gen is the ideal choice. And it's the best practice as well. So in the function name, just provide something like say IIT Goa function or something of that sort. I'm just going to keep it here. Like this, or I'm just going to do say add function, add hyphen function. You can also use the same function name, and then below that you see trigger, which means what triggers this method. We are just going to do a simple browser trigger, right? Click and trigger that. So in order to do that, we have to do HTTPS. So we leave it as it is. Don't do any change. Authentication part, because it's only a demo, I'm going to choose allow unauthenticated invocation, which means anybody who has this link will be able to access your function. But in this case, I'm going to choose that. But conventionally or by practice, in any organization or startup or even for business applications, you should not be leaving it for public use unless it is for public use and you don't mind others like spamming it or clicking it, sending automated requests. You have to use require authentication for your production applications. Here I'm going to use allow unauthenticated invocation. And if you open the extended settings, right, you will see runtime, build, connections and security settings. You can see what all options are available there, and we are not going to make any change right here for this. I'll just click next. So you do the same thing as well. Now we are in the 2nd page of configuration, 2nd and final page. And here we are going to write our cloud function. So this is the cloud functions editor. As you can see right here, the runtime is listed. In our case, like I said, I'm going to show Java 11. But if you have a choice or preference of your own language, feel free to use Go or Python or Node or anything of that sort. I'm choosing Java 11, and this is an inline editor. Alternatively, you can write the code in your own local and package it and then just upload it as a package, or upload it from cloud storage. Upload it and download it from cloud storage into cloud functions. But I'm not going to do all that. I'm just going to keep it as inline editor because I'm going to edit my code right here. As you can see, this is Java application, standalone application. There's a folder structure, there's a package, and within this package, we have this class called hello HTTP function.java. This is the entry point. This is the name of the class, and this is also the entry point for this particular cloud function, because we'll call this in the browser, and this is the entry point or the name of the function itself. I'm not going to change it, but typically it has to be the business application of what you're building. I'll just leave it as it is. Now I'm going to introduce a small change. This code is the boilerplate code that gets automatically populated by creating a cloud function. In this case, it usually prints only hello world, but now in this case, I'm going to change it or add a few lines of code just to implement an addition function in this example. So let's just do that. Public, because this method is public. Int, because it will return an integer. Then I'll say add as the method name. I don't have any parameter. I'm opening the braces, and here I'm going to do int c equal to a plus b, and let's declare and initialize a and b. Int a equal to 0, b equal to 1, and what is c, or a is 1, b is 2, what is c, a plus b, and just run c. This is a simple, very simple method. That's all I'm going to do. So now the c will get added right after hello world. The sum is, and outside the bracket, I'm going to do a plus. And this is where I'm going to call this method add, because it'll directly return the integer value here. Now that's it. I just added a small function. Now I'm not going to change anything else. In your case, you also can run the same method. I'll just paste this in the chat. Paste it right here. I'm going to delete the last part of this because it's truncating the code into two halves. So let me paste it 2 times. The first time is the first half, second time is the second half. All right. So this is what you have right now. I'm going to copy the second half and paste it there as well. Just copy from here till the end, and here you go. That's it. Now we have added, copy this and paste it, just and replace the functions body entirely with whatever you've copied from in 2 parts, right? From the chat. Now pom.xml is the dependencies file in Java in all Java related frameworks, Java based frameworks. So this one tells if you have any other dependency or other configuration parameters for the runtime, configuration parameters for the compiler, and all those things will be available in this particular pom.xml. And what if you're using any third party API or application that needs to be declared or that needs to be referenced as a dependency, it should be listed between the dependencies tags here in pom.xml, and just add a new line and add your new dependency. But I'm not going to add anything right now because it's a basic functionality which is covered with whatever is already there. So I'm going to you also leave it like that and then just click deploy. Now, if you notice, we've only changed one class. We did not change pom.xml. So it'll take about a few seconds for the deployment to complete. So I'm going to wait for the rest of you to catch up. At least I'll wait for about a minute or two. All right. So show of thumbs, use the reaction icon. How many of you were able to at least get to opening the cloud function and pasting the code? Okay, anybody else? It's still building. So there are 2 steps here in deploying the function. One is building, the other one is service. Building is where it's compiling, it's making sure everything is right. It's building the app, the application, and service is where it deploys and gets the REST API, the REST service for your function. And remember, we have made it unauthenticated. So the trigger is just clicking the link and opening the result in the browser. Now, resend the code. Oh yeah, sure, Ayushi. Let's see if it accepts the whole thing. No, it doesn't. Here is the first half. And here is the second half. Show of thumbs, anybody else was able to get to the step? Apart from the ones who already confirmed. Anybody else confirmed? I mean, are anyone else is confirming right now? Are you able to still get to the point for cloud functions? Or let me ask this way: anyone is stuck? Yes, I'll repeat the process briefly. Kalyan, are you able to get past your billing issue? Kalyan? So in my scenario, the building of your application mine is complete and the service is also complete. So ultimately, the program executed without any issue. That's it. So it shows the green check mark next to my function, prefix to my function name. So let me just explain this whole creating the cloud functions process briefly, immediately. I don't know, Kalyan's not responding now, but if you're there, this is for you, Kalyan, and also confirm if you were able to resolve the billing issue. Please confirm that. All right. So you land on Google Cloud Console, the landing page, and on the search bar, search for Cloud Functions. We clicked Cloud Function. In my case, I'm opening it in another tab to show to you. And this is what Cloud Functions landing page or console looks like. And in my case, since I have already created a few Cloud Functions, it's listed. And in your case, if it's brand new, you wouldn't see any list, but you can go ahead and click Create Function straight, and just click that create function and leave it as second gen environment. Function name, provide the name relevant to your business application or your whatever your code is going to represent. And then for trigger, leave it as HTTPS and authentication. If it's a production application or if it's any application that means business, then require authentication is the right choice. If you're just building it for demo and not many people are going to use your link and you don't mind just doing it one time, then just do allow unauthenticated invocations. But if you choose that, remember that your link should not be shared in public places, because then people can take unexpected advantage of your service and they'll start hitting your endpoint and you'll be charged for each call. You won't be charged for your app being deployed, but or your app being registered, but you'll be charged for your app being invoked each time there is a request, right? So you have to be careful. And then and then if you have any advanced security and advanced runtime build, memory, CPU, timeout requirements, you can configure that here. If nothing, if you want to go with default values, just click next. And when you click next, you'll land in the coding page, which is what we saw right now. We chose Java. You could have chosen anything of your choice that was available in that list. And we made some tweaks in the code to see if it works. And now let's go ahead and see if it works. As you can see, the link to the function is also available in the URL section. It is also available under the Trigger tab. You should see the URL. And as I said, this is Cloud Functions. So behind the scenes, it also creates a Cloud Run service. As you can see right here, that is also listed here. If you right click and open it, you'll be able to see what the Cloud Run service looks like from its console. It will have the list of services. It will let you create new service. It will it will let you deploy something on it. So that's what Cloud Run does. But right now, we are not going to that in detail. Let's just quickly test if our code worked. So how would we do that? Click the link that's available in the functions URL. And boom, there you go. We got the result. It said, hello world, the sum is 3 because we sent in 1 plus 2. So very simple. So this is your first program that you've written in Google Cloud and deployed it as a serverless cloud function. Yes, perfect, Ratik Kanta. Very good. Kalyan, is that enough for you? Can we move on? Do you have other questions? Are you able to clear the billing process? Can you confirm? All right, so this is what Cloud Function is. Now I'm going to pause for a second and for a few seconds, and I want to ask how many of you were able to get the result. I know Ratikanta confirmed. Anybody else can confirm if you got the result and got your function deployed? We have a bunch of folks. Okay, very good. This is awesome. So let's move on to the next few things. We now know how to deploy an application. Now we'll see all the things that we discussed in parts, right? We're not going to build the entire full pipeline or the full app structure, but we're going to look at the ML part as I promised, and then we'll quickly look at the generative AI part. Now we know how to create a runtime. Now, if you want to build a beautiful interface to it, go ahead and build it at your own time. There are several blogs that I've personally created. There are also material that's available on the Google Cloud documentation, so you can build more on top of the Cloud Function that we've just built. But now going back to data. So we all agree that we look at the BigQuery part right now. So we're going to do a simple hands-on, and the use case that we're going to build is movie success score. Success score is basically user rating or the IMDb rating for movies on a scale of 1 to 10. right? So we want to predict that. So that is the difference. The main difference between ML AI and generative AI is that in ML you provide the training data and you teach the machine to do stuff, to predict stuff, to identify pattern based on what you're training the model on, right? You're creating a model and you're sending training data as well, and then that model is basically trained on the data that you're sending. If it's supervised learning and unsupervised learning is slightly different, but there also you send in data, there also you create a model and so on and so forth. Which basically means that you're providing it with training data. Now AI is slightly different, or slight progress, or an integration from there, which can integrate the learning or the training that the machine does with human elements. Like there is a human element to it, taking data to another level. Like in terms of images, it involves human interaction a little bit more. Like for instance, video analytics come under AI and not necessarily just ML, because that involves real time data. It involves videos, images, or some data that is coming in from, like right now I'm speaking, right? If you have to use a quick summarizer to summarize everything I'm saying into one line or two lines, you'll use a summarizer API. Now that becomes AI. It's slightly different. And then we have generative AI. The difference with generative AI and these two AI and ML concepts is that with generative AI, you don't have to pass the training data itself for training the model. The model is already trained and the model is made available to you as an endpoint or as a studio user interface, which you can point and click and build your questions, or it is even made available to you as a library or anything of that sort. But you're not training the ML model, you're not sending data, you're just asking question and basically asking the model to generate data for you or generate content for you the way you want it to be answered. That is the main difference between these things. Now, what we're going to do is I'm going to paste a CodeLab link on the meeting chat. You will all open that and we'll go through a traditional ML model creation with BigQuery, only using SQL query. That's the best part here. You'll only use SQL query, but you would have built an ML model, and you will also predict the success score of your favorite movie using the ML model that we just created. And how we are going to predict it, what variables are we going to use as independent variables? We are going to use genre and runtime. So whether it's a horror movie, crime movie, thriller, comedy, rom-com, whatever it is, so that will be your genre. And runtime is how many minutes the running time is, the duration of the movie. That is runtime. So we are going to create an a classification model to to predict the success score of a movie or IMDb rating of a movie on a scale of 1 to 10. 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9 or 10, because these are the 10 labels. That's why I'm spelling it out, labeling each class, because we have 10 classes. So we're going to classify the movie into one of these 10 classes, or based on the independent variables genre and runtime. Okay, so that will create in two steps. One, you'll three steps actually. One, we'll load the data into BigQuery. Two, we'll create the ML model, and three, you will predict using the ML model that you created. And finally, I'll take 5-10 minutes to create a generative AI model and just ask a question and see what the model responds to you. So we'll do both today. For if you're just starting to BigQuery, starting with Google Cloud or any cloud for that matter, this session is extremely immersive for you because you started it with understanding what is cloud, to building a simple A plus B equal to C cloud function, a Java function. You deployed it serverlessly and you understood the concepts of what we did. And then you went ahead and stored the data in BigQuery, and you use BigQuery machine learning to create a custom model to do classification problem. And finally, you even use that data to get some generative insights. So we've gone through the whole journey as much as we can. So that is really, very impressive for if you're a first time cloud developer, or you're using the Google Cloud Console for the first time. This is really a great job from your end if you're able to follow me along and parallelly do this hands-on at your side as well. Right, so let's get started. I'll give you the link CodeLab, and you need to have the CodeLab open, because I'll say copy step one step one line of code number 2 or 3. So you have to copy it from there. That's why I want you to keep the CodeLab open. You're already on Cloud Console, so we don't have anything else required right now. So here. Yes, okay. Important thing which I forgot to say is you have to enable. In my case, I'm so sorry. Yeah, I forgot to mention that in my case, Cloud Function is already enabled. If you're brand new, if this is the first time you're using it, it will not have it enabled. So when you click create function, sorry, when you click Cloud Function from the search bar, it will ask you to enable the API. It will ask you to enable a bunch of APIs like Cloud Run. It'll give it, and it'll also give you a button that says enable API. Just click that. That's it. Nothing else is required. It's pretty self-explanatory. Explanatory. So I've just sent the link to the code lab in the chat. Please click that and have your code lab open. I have my code lab open here. It has 12 steps, out of which 4 or 5 are like boilerplate. Just introduction, which I have already given to you. Prerequisites, which you have already completed, at least till step 4. Just a few more requirements are pending, and then we'll jump right into storage in ML. All right. So how many of you are still doing the cloud functions? Okay, how many of you are following me or and are ready to do the ML part? Open the lab and everything. Please show of thumbs and confirm. Okay. All right, a few folks have confirmed. Thank you. Thanks a lot for confirming. Piyush has put his hand up. Do you have a question, Piyush, or you're just saying that you confirmed? You're confirming. All right, so confirming. Thank you, Piyush. So let's get started. So this is the code lab. I already gave you the introduction that we'll be using BigQuery for storage, BQML for creating the model. Two things which I didn't tell you. We are going to use Vertex AI's Palm API. Vertex AI is the ML AI and generative AI suite for Google Cloud, where you'll find all of the APIs and all the functionalities and products under related to ML, AI, and generative AI under this Vertex AI service. Palm API is the API that we'll use to ask question based on the movie data that we are going to store and generate answers using the model in Vertex AI Palm API. Cloud Shell. Now, Cloud Shell is very similar to the command prompt or any other prompt that you use in your operating system to interact with the OS, right? So similarly, Google Cloud offers Google Cloud's Cloud Shell, which allows you to interact with all these Google Cloud services. So when you initiate Cloud Shell, it will also allocate a Cloud Shell machine for you, which has some space to store your projects, files, and other things. And it has a Cloud Shell terminal and Cloud Shell editor, which is consumer facing. So you'll be able to see the Cloud Shell terminal. I'll show you how, which is where you'll run the commands to interact with the services that we are going to use today, which is BigQuery and Vertex. You can also alternatively do these things that we are about to do in the console itself, but we'll do part on the command Cloud Shell and part on the console. Okay, and you can also programmatically do it. And lastly, I'll also show you how to go to Cloud Shell Editor and see your project explorer, project structure from Cloud Shell Editor. All right, we'll see these 3 things, and I already told you what we built. We'll build an ML model. We'll build a generative AI application. You've already created the project. You've already associated billing account, and one last thing that's pending right here is launching or activating Cloud Shell. So how do you do that? Go to so you can close the Cloud Functions tab. You can close that and open console.cloud.google.com, or you can, in the Functions tab itself, right-click on the Google Cloud logo and open in New tab. So once again, do that. Have at least 3 tabs open on Google Cloud, so we don't close one. We just refer from the multiple tabs. So I'm having 3 Google Cloud tabs open by right-clicking on the logo. Google Cloud logo on the top left corner, right? So I have 3 tabs open. Now what I'm going to do is I'm going to search for, no, don't search for anything. We are going to activate Cloud Shell. Like I said, Cloud Shell is what lets you interact with the services. In the top right corner, you see the square, which contains the right arrow, angle bracket followed by an underscore. Now this is the activate Cloud Shell button. Go ahead and click that. Once you click that, you will see that the Cloud Shell machine is getting allocated and your Cloud Shell terminal is getting loaded. In the next tab that you have open, also click the same thing, activate Cloud Shell, but before it activated, quickly click open editor. Why quickly? Otherwise it will transfer the session from this other tab. It already did, but never mind, just click reconnect. So you have the terminal on one tab and editor on one tab. Expand it, otherwise it will be staying right here and it won't be visible to you. So just expand it so you can make all the, you can have it at your eye level and continue to do what we're about to do. And then the next tab, I have the Cloud Shell editor open. As you can see, these are the projects I've created so far in this particular instance, and it's still lying there. There'll be a point where it say you have too many projects, so there's no more space left. You can just clear up and work on it. But this editor is very similar to your Visual Code and other code editors. It has integration to your source code, version control, and all those things. So you can check how to do it. But I just wanted to show you what the editor looks like. So whatever you create from here, you can visually check for the files here in the project structure. Now, go back to the code lab. We have completed the requirements section. We have to go to preparing data, step 3. Click step 3. Make sure you went through introduction, requirements, and click step 3. I'm going to pause here for a second and see if there are questions in the chat. None. So can I assume that you're all able to follow? Somebody can confirm? Show of thumbs. Okay. So thanks for confirming. What all tabs with? No, it's not like you have to open tabs. Some people are comfortable opening only one tab and making all the changes in that itself. I'm just not comfortable with that. So just open console.cloud.google.com and click the logo, right click the logo and open it in new tab 3 times. Why? Because I'll tell you, we have the Cloud Shell terminal open in one, Cloud Shell editor open in another, and the third one, I'll keep it for BigQuery service. Right now, we have not kept it open. So that's what I meant. All right, now let's go to the code lab. And in the code lab, we are in step 3, which is preparing data. So for our use case, I've already created the data set, cleaned it, or made it actually at least I could say clean and ready for us to get started with the ML. But it's available in my GitHub repo. But you don't have to download the file. I'll just show you how the file looks in about a few minutes. But I'm just telling you, we will access this. We'll clone this repository and get the contents from this repo folder, project folder, into our Cloud Shell machine. So you can also visually validate that in the Cloud Shell editor. And we'll use other commands to actually create the BigQuery dataset, to create the table, load the data from the CSV, from my repository into the table that you're creating within BigQuery. And then as a next step, we'll start creating the model. Okay, for now, the first step, like I said, is storage of data. So for that, we have to create a data set. A BigQuery data set is similar to database in any other database, traditional database that you would have used. So we call it as BigQuery data set. We're going to create that using a Cloud Shell command that you see right here, BQ MK -- location with equal to US Central 1. You can choose any location, but make sure all the services that you're using for a specific project or application more relatively should live in the same region as opposed to having one service each in other location. I'm not saying it's always the case, but in some scenarios, it demands that the services demand that they are in the same location. So it depends. So you cannot generalize it. But in this case, I'm going to choose US Central 1 because I'm okay with that location for this data set. And the movie underscore insights is the name that I'm giving to my data set or database. Okay. So copy this command. Now we are going to create a BigQuery dataset from Cloud Shell command itself, from Cloud Shell terminal itself. Okay. Now, you can also create a dataset from the BigQuery console. You can also programmatically create it, but we are not doing all that today. We're just going to run it Cloud Shell terminal. So I've copied this command. Now I'm going back to Cloud Shell terminal here. I'll just paste this BQMK command and I'll hit enter. In my case, it's already there. So I'm going to rename the data set, but you don't have to do it. You just copy from the code lab and paste it here and hit enter. It'll ask you to authorize. Go ahead and authorize. If your BigQuery is not used before, this is the first time you're using BigQuery, it will ask you to enable the API. So if you have to enable the API instructions as it is, but if you're not getting any instruction there, but it's failing, the third tab that you have opened, on the search bar, type BigQuery, click that. And when you're clicking, it'll ask you to enable the API. Go ahead and enable it. Okay? That's it. Pretty straightforward. Just a button click, self-explanatory. All right. Now that the data set is successfully created, we also need to successfully clone the project from the GitHub repository because that project is what has the CSV file that I've loaded the data in that you can use for this use case. So go back to the code lab. Step number, we're still in step 3, preparing data. Second step is cloning the repo and taking that contents of that particular project into your Cloud Shell machine. So copy this and come back to the Cloud Shell terminal, paste it here and just hit enter. In my case, I already have this, so I'm not entering it. It will get cloned. See, it says it's already exists. This folder already exists. So I'm okay. I'm not going to create another one. But in your case, it should successfully say, it should say get a successfully cloned or project successfully cloned. Now I'll show you how it looks on the editor. Click the next tab where I have the editor open. And as you can see, the folder I just cloned from the GitHub repository is visible here. And you see the contents of this particular folder, project folder, is also available. I'll click BQ Cloud Shell commands. And when I click, sorry, not that one. I'm going to click movies underscore data.csv because that is the data file. See, this is what the data looks like that I prepared for our hands-on today. As you can see, it's a CSV comma separated, and all the fields that are available as part of this data. I have about 7,000 odd rows, I think. Let me show you. Yeah, 7,669. So let's just say 7,500 odd rows. We have so many columns, but we are not going to use them all for the ML part. We are only going to use genre, movie name, genre, and runtime of the movie, and the score that we're going to predict, which is the movie's success score. That's it we'll use for the model, ML model creation. Now, you've already seen the data. You know that this is under the folder movie underscore score underscore GenAI underscore insights. Don't do anything. Just go back to the code lab. In the same step number 3.3 says navigate to the project directory. So we created the project directory. Now let's navigate into it by selecting the cd command. Copy this from here, go back to the terminal and paste the cd command here. cd movie underscore score underscore GenAI insights, because that's what we cloned right now. Hit enter. Now we are pointing in that particular folder. At this point, we are going to create the table within the data set that we just loaded. That we just created in BigQuery. We'll create the table and load the data from the CSV into this table in BigQuery. All right. So show of hands, how many of you were able to get to this point? All right. Very good. Now let's get started quickly. Let's move on to the next step. Go back to the code lab and copy the BQ load command. Fourth step in step 3. Just copy the entire thing, because a single command will do two things for you. One is creating the table within the data set, and 2, loading the data into the data set, loading the data into the table within the data set that we just created. All right. So I'll just paste it here. In my case, I already have this table, so it will not work. But in your case, just copy it and paste it here. It will automatically assume that the name of the file is, the format of the file is CSV, because that's what you're giving here in the command. I'll show it here. You're choosing BQ load. Oops, sorry. Okay, we're here in step 4. It says BQ load. This is a Cloud Shell command for loading data. Source format is CSV, and we're skipping the leading row because leading row contains column headers. Movie underscore insights is my data set, which we just created in BigQuery. In other words, it's the database dot movie underscore score. This is what I'm creating right now. This is the name of the table I'm creating right now. And next attribute is movies underscore data.csv. This is the input file, and then followed by the column names and their corresponding data types are listed. That's it. Now copy this and go to Cloud Shell terminal and hit enter. Right? In my case, it will say that this table is already there, but in your case, it should create the table and load the data. Okay, mine is also complete. It has uploaded. So how many of you are able to successfully do this step? Show of hands, please. Now we'll move to the next one after this. Okay, awesome. A few of you have completed. Moving on to the next step. Now that we've loaded the data, created data set, created table, loaded the data, what is the logical next step? Just validate if the data is actually loaded, right? So for that, I'm going to map it in 2 places. I'm going to run the same query from Cloud Shell terminal and also copy just the query part and run it in the BigQuery console on the SQL editor tab. Okay, but first let's see it in the Cloud Shell. So copy the code snippet in the 5th substep of the 3rd step, preparing data. All right, so copy this, go back to your Cloud Shell terminal, paste this thing. Now what it does is BQ query, that is a command. Keyword, query is a keyword. Use legacy SQL, we have set it to false. We are using BigQuery SQL here, which says select name, rating, genre, and runtime from this dataset dot table name. Limit 3 means it take only 3 rows and show me the records. I'll hit enter. And as you can see right here, the results are fetched. Perfect. Now we have validated that the data is present. Now, how can we write the query in BigQuery console and validate this? Just copy the query part of it, not the whole BQ command, just the query part of the command. Copy it and go to the third tab where you have the BigQuery console open, right? If not, search for BigQuery on the Google Cloud Console landing page and hit BigQuery, enable API if it asks you to. Once you've enabled API, you would land on this page. Make sure you see the BigQuery pane on the extreme left, and in the in the next left, you should see Explorer pane with your project ID, the project ID. You should see the new table that you just created. You should also expand that, or right click and just click on the table. Once you click on the table, you should see, sorry, this is not a table, this is a data set. I did not create the table in this data set. So that's the problem. So let me just quickly go ahead and create the table. In your case, within the data set that we just created, you should be able to see the table that we just created, which is movie underscore score. So if you click that, you should see the schema of the table in first tab, details of the table, preview. Preview will show you the preview of the data that is available in the table. So now you can be sure that the code that we wrote to create the table, data set table and loading the data has all worked, and we've got the data ready. Now, the next step is to create the ML model. That's it. One single query we'll write to create SQL statement we'll write to create the model. And finally, we'll write one single query to predict using the ML model that we will just create. Okay. Go back to the code lab, go to step 4, data to ML. Now that the data part is complete, we'll go to the ML part. So here, there's only one SQL construct. What each of these keywords in this construct means is clearly explained in the query details. I sincerely encourage you to go and read that, because in the interest of time, I also want to allow you some time for Q&A. So we'll just finish this quickly. Just run this, copy this code. I'll explain the query, but we'll quickly see the result and go to prediction. Okay. I won't explain each and every construct here, but I want you to take a read of this details that's available. So here we are saying create or replace model. This is a keyword. Movie insights is a dataset name. Dot model rating by time, runtime and genre. This is the name that I'm giving to the model while we are creating it, right? We are creating a model. So we are providing the name to the model. It can be anything of your choice. It should match your requirement. In our case, it matches our requirement, which is to create a model to identify the user rating of movies based on its runtime and genre. So that's why my model name is like this. I've chosen this. Now within options, make sure you have all these parameters updated. And then the subquery part is where we are telling what our training data is going to be for this particular model. So you have to create a model. So you have to supply it with training data as well, right? So this is the part. This is a table we just loaded the data. And in that data, we have a column called data underscore cat or data category, which I have selected for created with two keywords, train and test. Majority of the data will have train on them because I want to use that for training. And there's like 50 to 60 records or something lesser than that as test records, which I'm going to use for prediction in the next step. So just copy this, go back to Cloud Shell Terminal, the first tab. No, not Cloud Shell Terminal, I'm sorry. Go to the third tab where you've opened the BigQuery console. So make sure you're able to see this. Close the table, and we don't need this anymore. So now click the new tab editor, sorry, new SQL editor tab, and paste the query that not this query. Copy the model query from the code lab in step 4 and paste it here. And this will execute and create the model right here inside the movie insights data set. It'll few seconds to create. After it's created, this is what it looks like. It will be created in your models topic. Under models topic, it would have added your model that you're just creating, which is model rating by runtime genre. How many of you are able to get to this step? Show of hands, please, or thumbs, please. Okay, Uday has a question. I've reached the BigQuery page. Where are we? Where do we need to run the query? So if you are in BigQuery, you have to expand. All you would be seeing is your project folder like this in the Explorer. Make sure you're seeing the Explorer pane, and you should see your project ID there. Expand the project ID. You should see the data set if you created the data set correctly. Expand that. You should see your table, and on the right you have the SQL workspace or editor. In other words, editor tabs. Just click the plus button. It will open a new tab and paste or run whatever query you want to do. You want to write here, and it'll take a few minutes for the model creation to run. We already created the table. Our current model is running. So I'm hoping that you will also be running this. It'll take about a few more seconds to complete. And then we can see the result. Okay, the model is complete actually. So let's go back there. Successfully created model named model rating by runtime genre. Go to model. I'll click the go to model button, and it automatically shows the configuration details. It shows the evaluation step, which has the threshold, precision, recall, and all these metrics that relate to a classification model. Why is it a classification model? I want to ask you that question, but we don't have much time. So I'm going to say, because we are classifying it in one of those 10 categories, 1, 2, 3, like I said before, right? 1 to 10. So we are classifying it in one of those categories. That's why we are using a classification objective method. And the model we are using is logistic regression. That is what is available here in the code that we just ran, right? The model query. Create model query we just ran has the logistic regression as a parameter. It is there in the explanation. Please go ahead and check it. So that's why we chose logistic regression, because we are going to predict a classification, a class. And for that, we use logistic regression algorithm. Now, if you see the model configuration, you see these metrics, success metrics of your model. Now, not success metrics, these are evaluation metrics. These will help you determine whether your model is performing good or not. Is it good? Not performing, but whether it's relevant to what you want to predict or not. Now, what does threshold mean? What does precision mean? You may have these questions. Just go to the code lab. I've explained everything in the result as well. Here, key metrics at a glance in step 4 itself in the end. Please take a read. You'll understand what precision, what recall is. These are all attributes of a logistic regression model. Finally, in the schema tab, you will see the target variable, the field that you're going to that is going to contain the result that you're predicting, right? So that is predicted underscore score, and the features that were those independent features that we relied on to make this prediction are listed in the features. The target variable is listed under the labels section. That's it. Now that we've created the model, what is the logical next step? Remember what I said? Predicting the movie score for a movie, your favorite movie, using the model that we just created. Now, this is very simple. This is another select query. That's it. This is a select query. Select star from. We'll use the ml.predict construct. And then in the model parameter, we'll use the keyword model followed by the model that we just created, right? Dataset name dot model name. And then the subquery actually passes what you want to predict. So I'm passing this query from this table. I'm taking like 30 records or whatever, how many ever records I've tagged as test data. I'm taking these records from this particular table and passing it to this ml.predict query. So it will predict the movie's success score, the test data. It will predict the success score of the test data movies that I have here in this table itself. So I'm copying this code, going back to Cloud Shell terminal, BigQuery console. You can use one of the open tabs, paste the query and run. It'll take a few seconds and you should see the result. As you can see in my screen, you should be able to see the results. The predicted score is the actual target result that you have just created the model for. It used the model you created to predict the success score of a movie based on runtime and genre. So the query itself has all the other fields because I have selected star from this particular table, right? So you'll see all the fields, but we only used two fields for determining the model, the prediction or the success score of the movie, which is genre and runtime. So you can see the data here. There's another column which you may be interested in, which is called the predicted score probability. The final predicted score is what you see in column 1. But column 2 has the probability of other scores to be the actual predicted score for this particular movie. But as you can see, 7 is the top most probable answer. So that's what is chosen as a predicted one single score. The other scores are all less probable than the topmost prior result. So that's why that's chosen as the predicted score. So I have how many ever records? I have about 72 records that are tagged as test data. So it has predicted the success score for all the 72 records. That's it. You have actually successfully created a model only using SQL query in BQML sorry, yeah, in BigQuery, and the data is living in BigQuery. So you've completed creating the model, and you use the model and actually completed prediction. So how many of you were able to get the prediction result? Can you show your thumbs to confirm? Okay, okay, very good. If you cannot see the model under movie insights, then probably you did not run the model query or you created it in another data set. So yeah, make sure you see that particular model there. If you can see, I can show my BigQuery tab. See movie insights, expand it, and under that I can see the model created. If the model is still running, you might not see it yet. If the model completed, then you should see the models. If the model creation step is completed, you should see that under your models topic under the dataset movie underscore insights. That's it. Next step is generative AI. I already told you what the difference between ML, AI, and Gen AI is. Going back to the code lab, that is the last step, which is data to generative AI. So we will use the construct generate underscore text. That is like we used ml.predict. Here we use generate underscore text. And we are going to use the model from, like I said before, Vertex AI's Palm API, the text Python model, because we want to make a large language model based generative AI inside. So this is the technical part aspect of it. The API is coming from Vertex AI and the data is coming from BigQuery. And together we are going to expose the Vertex AI API as a remote function in BigQuery SQL. Only using SQL, we are going to do this generative AI application as well, right? So for that, we have to make BigQuery and Vertex AI talk. In order to make them talk, we need an external connection. So this external connection will allow BigQuery to invoke Palm API, which is in Vertex AI, as a remote function. And we have to provide access for that particular external connection to access the Palm API from Vertex AI, right? So that is what we're going to do. It's very simple technology-wise. Data is in BigQuery. We'll use the generate text construct in BigQuery, BQML, and then the API that it will invoke to do the generative AI itself is Palm API, which lives in Vertex AI. And we'll use external connection to establish the connection between the two. So these are the three things. Now, business-wise, what is the functionality? What is the use case that I'm going to build? Right? We already have the data for movies ready. So we are not going to create new data. We'll use the same data. But instead of creating a manual ML model and predicting using it, I'll provide the data itself as a story to generative AI's prompt and then see what response it is able to provide as a prompt, the answer to your question, right? We are basically asking the model, text Bison model, to generate a response to a query that you're going to ask right now. That's the business case. So the question I'm going to ask is, what are the factors that you consider? How are the other factors affecting the success of a movie by making the score as making the success score of a movie greater than 5? So what are the factors that influence a movie to be in a rating that's higher than 5 out of 10? So the question I'm going to ask, and let's see what the generative AI tells us. Okay. So in order to do that, we already have the data. We are going to use the same data set, same table, same rows that we created for ML model. We are not going to change anything. The next thing, like I said, we have to create an external connection because BQML needs to talk to Vertex AI. So let's see how to do that. Go to click step number 7 in the code lab. As you can see, you have to get to this point, right? So go back to BigQuery console. So once you're on the BigQuery console, in between the SQL editor and the BigQuery the leftmost pane, you should see the Explorer pane. In the Explorer pane, on the right side, you should see the plus add button that I'm showing in my screen. Click that add button. And once you click that, it will pop up the popular sources. Select connections to external data sources, the third item in the second row. So choose that, the first row, I mean. And then under connection type dropdown, you need to select Big Lake and remote functions. Why? Because we're using Vertex AI API as a remote function. So you need to take that option. Connection ID, go back to the code lab and see what connection ID I have provided in the text. Copy that because we will use that in the query as well. We need to provide the connection label in the query. So make connection ID label in the query. So make sure you use the same connection name. So if you click step 7 in the code lab, second subpoint there has the BQ underscore LLM underscore connection as the connection name. I'm going to copy that, paste it here. And then region. Remember, I said keep in the same region as BigQuery dataset. So we chose US Central 1. So click region, and under region, choose US hyphen Central 1, Iowa. So I'm going to select that. So provide all this information and quickly hit create connection. I'm not going to click that because I already have this connection created. In your case, it won't have. So click create connection. But before you do that, it will ask you to enable the API. So if it prompts so, just click the button. That's it. You would have enabled the API and do the step and click create connection. It'll not even take 1 second, 1 or 2 seconds. You will have the external connection listed under the external connection topic. Click that. Once you click that, you should see the service account ID as the last configuration info or connection info. Now just copy the value of your service account. This is important. Take it to your clipboard or note it somewhere. We are going to use this service account and provide it access to actually access the Vertex AI, right? So this is the service account of the BigQuery. This is the external connection, service account of the external connection. Now we are going to use this external connection service account and provision it with Vertex AI permissions, so it is able to make BigQuery and Vertex AI talk. So how do I do that? Right click on this Google Cloud logo again, open link in new tab. So the fourth tab, it will land on the Google Cloud console page. Click the 3 lines on the top left corner and you choose IAM and admin. Once you choose IAM and admin, it will take you to the account security and access control and other IAM related authentication management page. Once you're here, scroll down, it should show permissions tab selected, and under that view by principals tab selected. Under that, you should see grant access below that. So click grant access. Here, paste the service account that you just copied. Paste it here, enter, or select the first option that shows up, because it's, in your case, it won't show anything because you're just pasting it for the first time. So make sure the principal that you copied, the service account ID that you copied, is pasted here in under new principals, in new principals section. And in assigned roles, there's a drop down. Click the drop down. And in the filter, type Vertex hyphen, sorry, not hyphen, just type Vertex space AI space user. It should show Vertex AI user. Just click that and you should be good to go. Just hit save. That's it. In my case, it says no change. Principal already exists on the policy. In your case, it will actually create the service account, provide the Vertex AI user permission to the principal that you copied from the service account ID. That's it. This is the external connection creation and access provision. That's it. You've completed step 7. It's all there. Now, the second last step of this hands-on, which is creating a remote ML model. Like I said, we are going to use the Vertex AI's API as a remote function from BigQuery. So if you can see here in this particular step, create a remote ML model, you can see that also implemented with just an SQL, only SQL query, right? So copy this entire query from here. Statement from here. Go to third tab, which has BQ. You can close the IAM tab. We won't use it anymore for this session. So click the BigQuery tab, click the plus icon and open another clean empty tab. Paste the stuff that you just copied. Okay, I didn't copy. Yeah. So paste the thing that we just copied here. Create or replace model. We're going to create an LLM model in BigQuery using the model that's already there in Vertex. So create or replace model. Model will live dataset movie underscore insights. The name of the model should be LLM underscore model. It can be anything that you want. In this case, I'm using LLM underscore model, and followed by a keyword called remote, because we want to assign the Vertex AI's API text bison for the generative AI based on text as a remote function in BigQuery. So say remote with connection. So what connection are you going to use for these people to talk, for these things to talk, which is Vertex AI and BigQuery with Vertex AI. So we are going to use the external connection that we just created in the previous step, right? So region dot connection, external connection name. That's it. This is the format of the external connection, region dot connection. Leave it as it is because you copied it from the code lab. It'll work fine. Options. This is a keyword followed by remote service type. This part, cloud underscore AI underscore large underscore language underscore model underscore v1. This is the generative AI API, Vertex AI. So run this. It'll take very few seconds and the model will be completed. Once the model is created, it will show this message: successfully created or replaced model named LLM model. You can click go to model and see what it looks like, but you don't need to. We don't need to copy anything from here. So just close it, come back to lab, model is created. Now the last step here, so there are two steps, but we are only going to do one step because the other one is both are same thing. We are going to write an SQL query to use the model we created and to answer the question that I asked before, right? So why are there two steps then? I'll tell you. The first one also does the same thing, generate text. The second one also does the same thing, which is generate text using the model we created. But the only difference between the two is the result of the step number 9 query does not structure itself because we are not passing any unnest parameter. The result will be nested and it will not be properly structured for your understanding. Whereas the step number 10 has the same query, but it has the keyword unnest in its implementation. Sorry, not unnest. We are using flattened JSON output. We have flattened out the result, so it is easy on our eyes to understand the result. So that is why we are going to run only step 10 now. Both you can run and understand what each clause means, but right now we are just going to run step number 10. So we'll get a structured result. So copy this query from select query from step number 10 in the code lab, go to the BigQuery part, BigQuery SQL workspace editor part, open another tab, paste it here. Now see let's go over the query. Select star from ml.generate text. Now that's the keyword. Model is the keyword, and the model name is dataset name.model name, which we created. And within that is the main part. This is what is called the prompt engineering for SQL based LLM, because you have to make sure. So this is the important thing with large language models and generative AI, right? You have to make sure you frame the question and provide as much backing data for it, so it searches for answer from the data and not assume things by itself, right? So that is exactly what we have done. What I'm doing here is I'm asked, this is my prompt. From the following text about movies, what do you think are the factors influencing a movie score to be greater than 5? Where is the following text? This is the following text, movie underscore data. Text? No, it's a variable. It's a parameter. I'm passing this parameter from a subquery. So what do I have in my subquery? Basically, remember all the 7,000 odd records that we created in a table in BigQuery. So if what I've done in this particular subquery is I've taken all the attributes from the table or from each movie. Like I've taken the columns from the movie and concatenated the entire table. I've not taken all 7,000 rows. I've taken only 50 records and concatenated them by rows. Like it's not the fields are not concatenated, the rows are concatenated, basically to form a full 50 movie story. So basically this is how I've aggregated this. A movie named dash from the country dash with a sensor rating of dash, sensor rating of R or something, right? And a budget of dash, produced by dash, with a runtime dash, and in the genre dash, starring who is starring, like filler for that, and has had a success score of, this is the predicted score, or this is the success score of that movie. Now I'll get this information for all 50 rows that I'm selecting in this particular query. Basically I'm taking 50 that have a success score greater than 5 and concatenated in this fashion as my prompt data. So I'm passing this in addition to the main prompt question and the data that it needs to use. It has to understand this data and basically find answer to that particular question I have asked. That's it. That's exactly what we're doing. The other attributes about the query, like temperature, max output tokens, are all really important. Head over to the code lab in the same step number 9. All these additional parameters, important key parameters of prompt engineering or generative AI based LLM, it's all made available here, right? It's available here, it's described. So please go through that and understand it at your time. Let's quickly run this and see that our model works and we get an answer to that particular query. So I'm running this. It'll take a second to show the answer. There it is. Okay, so there is one answer. As you can see, the result is pretty structured because we asked the proper, we wrote the flattened query, right? So it is saying based on the given information, the following factors seem to influence a movie score to be greater than 5. So what are those? Genre. All the movies with a success score greater than 5 belong to crime genre. Censor rating. All the movies with a success score greater than 5 have a censor rating of R. Now there is more to it. We cannot see everything in this result set. Tab it in this result set small section query section. So I'm going to export my result to a local file just to show you what the result looks like. So I'll open the file and see what it has. I'll just copy this and open a new tab and paste it here. That's it. It pretty much has only that. It has budget, another field saying most of the movies with a success score greater than 5 have a relatively high budget. So that's all. These three things were inferred by the generative AI model that we used. That's about it. So we have successfully completed, understood runtime, created a hands-on with the cloud functions. You've understood the difference between ML AI and generative AI, and understood BigQuery as a storage option or analytics option. We did some data storage, querying, analytics, and insights with BigQuery. We created ML with BigQuery. We created generative AI application with BigQuery. And we are ready to end the session. So if you're able to successfully do till this step, please show me your response with thumbs up reaction. Okay, so some of you, awesome. I see some results in the chat. That's amazing. Very good, folks. Thanks a lot for sharing. I'm really glad you were able to get up to this point. So I'll unshare my screen. I'll just pass in a few links because we have similar hands-on sessions in a program called Code Vipassana. Already like close to 500 folks have registered. People are registered because that particular season is fully generative AI based. You'll build applications, full stack applications, and different teams and different frameworks like Java, Spring Boot, Python, Django, Node, Mean Stack. Several tracks we'll be building, and there are 7 projects and 3 silent finale projects. So totally, if you complete 5 projects out of 10 hands-on, you will be given a certificate as well. And then a lot of folks who were consistent in the previous seasons were selected to be part of the core leads team, and they were also able to build more projects. And one of them actually was nominated for Google Cloud's, not Google Cloud's, Google's Open Source Award, and he also actually got approved for the award. So not that you have to go to that extent, but you can at least start participating in Code Vipassana sessions as a learning ground for you. So I'm going to give you the link to register, to learn about the program and to register. It's all on the landing page itself. So I'll just give you the links here. It's Code Vipassana double S, right? And single P, codevipassana.dev. That has all the details, and it has sign up links as well. You already have the credits, so you're good to go. And lastly, I want you all to sign up to become Google Cloud Innovators, because this will put you on the track and eventually give you more details for learning resources and all things that happen within Google, like events that you may want to know about or want to learn about, or even attend in some cases. You'll get information about that in your inbox if you sign up to become a Google Cloud Innovator. And eventually, if you want to be on the track to become Innovator Champion or GDE with Google, you need to have or Google Cloud. You need to have these. You have to first be an innovator. Only then you'd be eligible to become an Innovator Champion, and that comes with a lot of perks. So that's like a Cloud GDE, but you also have Google Cloud GDE. So either one requires you to be an innovator. You can sign up. It's free. And lastly, updates about new hands-on and all Code Vipassana sessions are usually launched in this meetup group. So I've also given the link to, no, that's the same link I pasted again, I think. So no, meetup group link I've pasted. This is called Datapreneur Social. So you can be a part of Datapreneur Social meetup group. It is also free. It's just that all hands-on sessions, everything that the core team and the other teams conduct are scheduled in this meetup group. So that's why I've asked you to be a part of it. So that's about it. I'll stop here and over to you, Akash.
All right, then I think now we can wrap up this event. First of all, JDC IIT would like to thank Abirami ma'am for today's hands-on workshop. We can see many students kickstarting their Google Cloud journey today, and it was a great pleasure for us to have you as a speaker today. And we would be glad to see you again in one of the future events of GDSC IIT Goa. And also, I would like to thank everyone for attending and staying until the end of the session to learn beyond academics, that too on a weekday. And now today's session is officially over. If you have any more doubts or queries, you can put it in the comments. And yes, that's it. Thank you all.
Thank you so much, Akash. Thanks everyone for joining. I have a few questions around. I mean, I'm receiving a few questions around what is a prerequisite to be a part of Code Vipassana. There's no requirement as such. Anyone can participate. I've given the link. It's codevipassana.dev. And if you'd like to connect with me in my socials, it's abirami.dev. You can find all my social pointers in there, coordinates there. So just feel free to connect with me. Thank you so much. I'm really looking forward to seeing you all in Code Vipassana. And yeah, let's keep in touch. Thanks. Bye.